The Brady Bunch. The Brady Bunch. I actually don't know the theme song. I was just making that up.
That's awesome. And with that lovely introduction, this is the Brady Bunch. No, we're not the Brady Bunch. Welcome to Community Office Hours for Consul. I'm your host, Rosemary Wang, for today's open Q&A with the Consul Education team, one of my favorite teams. If you have any questions or comments, we'd love for you to interact with us in the chat. If you do, please keep in mind our code of conduct in this virtual space. In general, be welcoming, inclusive, friendly, and patient, be considerate, be respectful, and be professional. You can review our code of conduct at hashicorp.com/community-guidelines. Now, on to our office hours. If you have questions, please ask Eddie and Carl. But first, let's have some introductions. We'll start with Eddie, and then we'll have Carl for introductions.
Hey, everybody. Yeah, thanks for coming to HashiCorp's Community Office Hours. My name's Eddie Rowe. I'm a product education engineer for Consul. I help create content to help you guys around the world grow your skills with Consul and other enabling technologies. Happy to be here today.
And hello, everyone. My name is Carl Cardenas, and I am the product education manager. So Eddie is on one of my teams. So I have Consul, Nomad, and Waypoint, and sometimes other HashiCorp products. But again, like Eddie, thrilled to be here today and excited to showcase some of our newest content.
Yeah, I'm very curious. Is education engineer something that you had to build your professional career around? Like, how did you end up becoming an education engineer in the first place?
Eddie, you want to tackle that one first?
Yeah, sure. So honestly, I didn't even really know a role like this existed before joining HashiCorp. But what happened to me, it was just kind of a series of happy accidents throughout my career. I built up, I have over like a decade of different kind of IT background and DevOps related positions. So I just kind of naturally fell into a training role in a lot of different roles that I played before on that job. So when I saw this posted, already been using some of the HashiCorp products and very familiar with the HashiCorp brand. So it just kind of felt like a natural fit for me. And I've really enjoyed, kind of growing with the role and, creating content to help other people learn.
I was promised a t-shirt when I joined, so that's why I'm here. But no, in all seriousness, in a previous role, been an engineering manager. On my own time, I always caught myself writing blogs on Medium and just teaching others, and it's just something that comes to me naturally. I just really enjoy it. It's a lot of personal gratification, and I'm sure Eddie feels the same way. So when I found out that, hey, I can get paid and do this for a living, and it's for HashiCorp, I'm like, why not? So yeah, in terms of like what leads to you to become an education engineer, every one of the engineers on the team comes from a different background. The one thing that unites all of them is that they enjoy writing, teaching, and exploring new features of the technology and sharing it with others. But there's really no recipe to success. Actually, the more diverse, I feel, is what makes it a better team.
It's really fun. Speaking of t-shirts, we also discovered a fun fact right before we started the stream. Apparently, everybody has mixed wardrobes of HashiCorp t-shirts or no t-shirts. Eddie, would you explain, and Carl, would you explain how many shirts or lack thereof you have?
Sure. Yeah, I I have 0 shirts, but I have a pair of HashiCorp socks that I really love. I wear them once a week. Makes me feel really nice and warm inside, but nothing on the top layer yet for HashiCorp. I'm hoping to earn my Consul shirt soon.
We'll see, Eddie. We'll see. I had 7 HashiCorp t-shirts before I joined HashiCorp, so I guess you can say I've been a fanboy for a long time. So yeah, a little bit ridiculous.
Wow, I'm jealous.
One time or another, we'll have to get you a shirt, Eddie. All right. Last question before we get into demo, but what if someone wants to be an education engineer?
Oh, thank you so much for asking that. Yes, if you're interested in becoming an education engineer, we have an opening right now, and it's actually a really cool opening that we have right now. Normally, an education engineer is normally focused on one HashiCorp product. We are hiring for an education engineer that will be filling a floating role, meaning that you will have the opportunity to play with various products and help out, such as Nomad, Packer, and Waypoint are some of the things that we're looking for right now. So Rosemary is going to add a link to the job opening, but if you're interested in it, please feel free to hit me up on LinkedIn or in my email address, which we'll add to chat at kcardenas@hashicorp.com. Feel free to ask me any questions about the role, what it entails. But yeah, if you love teaching other people and want to play with HashiCorp products or open source software in general, this is the role for you. I think you'll like it.
Awesome. I'm excited. Like I said, it's one of my favorite teams to work with. So I'm very excited if more people join. All right, Eddie, ready for a demo?
Absolutely. Yeah. Let's kick it off.
So what will you be showing us today as you share your screen?
So today I'm going to be going into some of the capabilities and benefits of true observability within a service mesh. And without getting too much into some of the vocabulary right now, basically what's going to happen is just over the talk, I'm going to go over a high level overview of service mesh and observability. I'm going to talk a little bit about these concepts, and then I'm going to leave some space for questions before we dive into the demo. After we handle those, we'll run through the whole demo and you'll be able to see some of the hands-on access of the tools. And then we'll close out and we'll take some more questions afterwards.
Awesome.
So I'm going to hop right in and start sharing my screen. Oh my gosh, look at all these screens. Okay, we can start here. Perfect. Cool. So my screen should be up now. Everything looking good?
Yep, everything should be good.
Awesome. So yeah, like I was saying, I'm going to show you some of the capabilities and benefits of observability within a service mesh. The reason this is important is because with all the wonderful benefits of scalability, resiliency, and security that a service mesh brings about, some new challenges are presented because of that. One of those challenges is getting timely insight into the performance, health, and communications of having a varied, rapidly evolving application ecosystem. So in that, two concepts are really important here: service mesh and observability. A service mesh manages all service-to-service communications within a distributed system. This demo and discussion assumes you are somewhat familiar with the concepts and benefits of service mesh or a microservice architecture. For those who haven't yet explored these concepts, Rosemary is going to send out some links to our hands-on guide so you can explore them at your own pace. The other main concept that we're going to discuss is observability. True observability consists of metrics, logs, and traces. Metrics are a measured value derived from system or application performance. You can gather metrics on system uptime, response time, requests per second, how much CPU or memory an application is using, really from any part of your stack. The second component of observability is logs. Software and applications love to talk. Virtually every component of a distributed system generates logs of actions and events at any point in time. These include comprehensive system details and specific times and timestamps that these events occurred. The final component is traces. Although logs and metrics might be adequate for understanding individual system performance, behavior, and performance, they rarely provide helpful insights and understanding into the lifetime of a request throughout the distributed system. A trace represents the entire journey of a request or action as it moves through all the nodes of a distributed system. So this is a ton of information that your systems are generating. What is all this information good for? One of the top things is health monitoring. Identifying node, service, process, and application availability is a huge benefit of having observability in your ecosystem. The second thing is troubleshooting. Events will arise where things don't perform as expected. So identifying and resolving issues much faster is a huge benefit to being able to have this insight into your system. It allows you to easily dive into details when your health checks begin to fail and figure out what's going wrong in your systems faster. Another reason it's really useful is observability gives you performance measurement. Having the ability to pinpoint bottlenecks and analyze system behavior trends leads into a final good reason for having this, which is continuous improvement. Being able to identify these high value areas for optimization and improvements in your application stack, it's extremely useful to have in this world of CI/CD when everything is moving and developing so quickly. So together, metrics, logs, and traces really empower you to know the ins and outs of your distributed ecosystem. So that's the what and why of service mesh observability. Now I want to give you an overview of the demo environment that we're going to use to show these concepts in action. In front of you here, that's been sitting on my screen, is an architecture diagram of our demo environment that we're going to spin up today. One note to make about this environment, you'll notice that it's all encompassed in a Docker Compose environment. We use Docker containers for the service mesh and observability suite in this environment, but in reality, you can use Consul to create a multi-platform service mesh comprised of Kubernetes resources, virtual machines, Docker containers, really anything that can run the Consul binary. It doesn't have to just be a Docker Compose environment. So on the left side here, you'll notice the Consul service mesh. We have a 3-tiered application inside the Consul service mesh. The ingress, the web, and the API are running example services. Each component of this 3-tiered application communicates with the others through a Consul proxy. All of these containers are pre-configured to send their metrics, logs, and traces to their corresponding ingestion points, which we'll talk more about those details a little bit later. On the right is the observability suite. We're going to use Prometheus and Node Exporter to generate metrics and ingest metrics. We're going to use Loki to ingest and manage the logs, and Tempo is going to ingest and manage our traces. Grafana up at the top, you'll notice it's going to be used to visualize each of these observability components with different kinds of customizable dashboards and graphs. So for this demo, we're using all open source observability components. You'll notice the Grafana stack and Prometheus. We're doing this because they are free, and you can grab these easily and have all the core features necessary to explore the world of service mesh observability. In an enterprise or large-scale production environment, it's common to use platforms like Datadog for these purposes. Each step of the demo I'm about to run through is documented step-by-step in our observability Learn Guide. So feel free to check out the posted link that Rosemary is going to send out to get hands-on experience with this exact environment on your own machine. We're also going to post out a direct link to the GitHub repo for those folks who are ready to clone and get going right away. So that's kind of the preface to the demo before we jump in. Rosemary, are there any questions that have come up right now?
Yeah, well, I have a few questions, and it's really interesting. So in this space, right, if you don't have a service mesh, what do you do? Do you just sort of add the logs in your application and hope that it's going to the right place? What does this usually look like if you don't have a service mesh in place? I mean, distributed tracing is already known to be a really difficult thing. And what does a service mesh, in terms of a developer experience, what does it add or how does it help?
Yeah, absolutely. So in traditional environments that are monolithic environments, this is a microservice kind of environment, you have these individual solutions like Splunk or, they can even use some of these open source components there, and it's very segmented. You have these services that ingest logs or metrics kind of distributed in an agent kind of fashion on each of these machines. Then you use tools like Ansible or Puppet to configure some of these agents and send them out and centralize the logs. There's generally in some of the large enterprise environments, there's teams dedicated to operating some of these platforms. Where the service mesh, I think, really benefits is with a Consul service mesh, you instantly have insight. Since things are going through the proxy already, you have insight into getting a lot of this information. The metrics, Consul metrics are handled by Consul. The traces are sent out and generated by Consul's proxies. So there's a lot you can grab, that Consul and service meshes kind of help keep all together rather than having all these different components and trying to put together that picture using separate disparate systems.
And
so,
go ahead.
Oh yeah, go ahead, Carl.
No, I was going to add, and just to add into it. So if you don't have service mesh, if I'm going to give an example that some might relate to, if you've used AWS, maybe their X-ray feature, what Eddie is pointing to that you can get with Consul out of the box using the UI is because it's going through the proxy, you can kind of see how it's interacting with other services in a visualizing manner that sometimes is easier to understand rather than just looking at trace logs. So that's where the service mesh capability really enhances with the tracing capability. So Consul is not intended to solve your tracing monitoring, but it's definitely something that can help you identify the problem more quickly, and then for you to follow up on using your logging solutions. Like Eddie in this example is using plenty of the open source tools.
That's cool. A funny question I get, and I posed it to you just out of curiosity what your thoughts are. But a lot of people say that, we already have a lot of monitoring tools. We already have agent sprawl because we've added these agents and more agents, and they're all for different things, right? Security events monitoring, tracing, metrics, other telemetry. What would you say if someone asked you, doesn't service mesh add another agent onto the machine?
Yeah, that's a good question. Yes, the agent would add another item to the machine, but you got to look at a big picture. What is the problem that you're trying to solve for your organization? Is it to achieve zero trust? And why do you want to achieve zero trust? Is it so your executives can sleep better at night, knowing that if they get hacked, that applications are communicating with each other securely? Or is it because you want to be more prepared from a resilience standpoint, leverage something like Consul prepared queries to failover? So yeah, I definitely understand that you don't always want to add a new agent or a binary to an instance, but if the pros outweigh the cons, then it's definitely worth it. And with Consul and the capabilities you get with service mesh, the zero trust, and the ability to leverage intentions to simplify auditing and management of securely applications talking to one another, I'd say it outweighs the need for it outweighs the con of adding another binary to an instance.
Absolutely. Yeah. And to add on to that, like Karl was saying, the big picture, if you zoom out, there's economies of scale to using service mesh over traditional environments, because in traditional worlds, you have things, different appliances that you're scraping a lot of these logs from that don't come with standard operating systems, different types of vendors. You're having to point syslogs in certain places. Trying to get traces from them may require other, multi-$1,000 licenses and license agreements to have the tracing package or other kind of like metrics packages that are part of them. There's layers of complexity there that go a lot deeper per vendor solution, whereas the service mesh and having these standardized like Consul, you get a lot of economy of scale of having this standardized like flattened procedure to get these metrics, logs, and traces from in service mesh.
All right. I don't have any other questions from chat. So if you would like to show some code, I think we're ready.
All right. Great. So we talked about the demo. Now let's go ahead and hop on in. That is not Visual Studio Code. This is. Here we go. Okay. So I want to talk about what's already been done here because you're already seeing a bunch of stuff pop up on the screen. What I've done is already completed a lot of the prereqs that are listed in the GitHub repo. And also in the Learn guide, things like installing Docker and the Loki drivers is already done. I've already cloned the GitHub repo over here. I've run the environment locally several times to test. So basically the container images are already pulled and ready to go. These prerequisites are steps that should only take a few minutes when running the demo environment on your machine. I just want to make sure everything was clean and prepped for this. So with that said, and the prereqs done, what I'm going to do is I'm in this directory where the Docker Compose file is. So I'm going to run Docker Compose up in detach mode, which means that the logs are not going to all fill up on the terminal here once the images are built. Those are going to go to their individual containers. The first thing that you notice is happening, the Docker Compose file directs a network to be created. This is a private network for all the resources to be built inside. So you'll see each of the containers starting to be fired up. And this is all happening from the Docker Compose file here. When you download it in the repo, you can check out the configuration to see exactly what resources are being spun up. Okay, so it looks like everything is done and spun up. So I'm just going to go check the Docker desktop GUI. And it looks like everything is also green here. So we have a nice stack that's local and ready to go. Now that we have the stack, I'm going to hop on over to the browser. And first, we're going to go ahead and stop by Consul. What I want to show you here is basically this is the service mesh environment aspect. So in the Consul UI, you see these different services that are pre-configured. We have API, ingress, and web. And what you'll notice is each of these services are connected with the proxy. So they're using that Consul proxy basically to talk with each other. So these are the different services that are running. Everything is healthy and passing the health checks. What we're going to do next is go check the other part of this here. So we just saw the Consul server. We're going to check the actual application itself. So this page is the application. We use an application called Fake Service and it just kind of is like a nice visual representation here. We have the ingress, which is the first point that the application hits. It then goes through to web, and then it goes through to API. And it's going through the proxy here. Everything is white. It would be red if there was errors going on. We use ingress, web, and API. In your ecosystem, it could be much more complicated. This could just as easily be, API, web, and database. Become much more complicated than this. This is just to show a nice standard 3-tiered application. So every time we refresh this page or visit this page, this is generating metrics, logs. It's all pre-configured. And also the traces, it's all being pre-configured to be scraped by our different observability suite components. So let's talk a little bit about those and how they get ingested. As far as the metrics go, Prometheus and Node Exporter are used to generate some of the metrics. So here on the targets page of Prometheus, we can see that we have a few different endpoints. One of those is Consul, Node Exporter. You see Prometheus being scraped here itself and Tempo being scraped. Each of these endpoints are generating a lot of different metric data. Prometheus is just kind of the tool that scrapes and centralizes that metric data, which Grafana will then help us visualize. So that's metric data. As far as the logs find their way to Grafana via the Loki driver Docker. I'll pull up our configuration file here. A lot of this is pre-baked in, but you can see in the compose files that this configuration is basically passed in to on each of the containers. So all logs are centralized in the Loki service. Traces, finally, traces find their way to Grafana through the Tempo Docker configuration on each containers. And those traces are in Zipkin format. There's a few universal formats that traces come in that are open source. We use the Zipkin format in this demo. An important reminder before going forward, these configurations shown in this demo in the code are for exploring the concept of service mesh observability. These are not production grade prescriptive practices. So please don't copy this configuration file and start running it in production.
Just to summarize in general, though, the config file, does it have ACLs enabled, TLS and the gossip encryption? Does it have the configs there or no?
So it has some loose configurations. Some of the other more detailed secure configurations like secure ACLs and secure certificates and the gossip encryption, we have in that same repo that you would download this from, we have other guides and other tutorials that'll run you through the entire secure configurations so you can understand how to secure Consul and service mesh encryption in there. But this one is a very loose one.
Got it. For those who are not as familiar with Consul config, please correct me if I'm wrong. is this a set of configs that are passed as part of Consul? There's also a set of configurations you can optionally configure as each service, correct? So in this case, are you doing the Consul configuration or is it per service?
Gotcha. Yeah. So you can configure the Consul configuration a few ways. You can bootstrap it with configuration files, or you can do it through the HTTP API. In this case, for the simplicity of being able to spin it up and start exploring some of the concepts, these are pre-configured configuration files. So as soon as Consul comes up, it has a base configuration and understands some of the health checks and services that are going to come along with it. Did that answer your question?
Yeah, that's perfect.
Okay.
And as a note, you're using Zipkin. Envoy did add Jaeger integration, but do be careful if those are in the chat who are checking this out. Make sure you check what Envoy version you're using and whether or not it is compatible with Jaeger tracing if you do use Jaeger.
Oh, that's super useful. Good point. Cool. Yeah, thanks for those questions. Those are great. Okay, so we have kind of a picture of where the metrics, logs, and traces are coming from in this environment. So what we're going to do now is we're going to hop over to Grafana. And first, what I want to show you is the data sources here. So in Grafana, in the data sources tab, you'll see Loki, Prometheus, and Tempo are pre-configured. So we have the logs, the metrics, and the traces that are available here. What we're going to do next is we're going to go over to the Explore tab in Grafana, and we're going to select Loki, which is the logging service. And we're going to do a little example here. If I can get over to this tab. Yes, I can. Okay. And what we're going to do is we're going to copy this search parameter from the README file. It's a little easier to copy than to type out. And what's looking for here is it's looking for basically logs for the container name web, and it's looking for text that contains trace ID. And so when we refreshed this application here and accessed this application, we generated logs and traces for that through an HTTP call. So we're going to go ahead and run the query. And you'll see down here, you'll see some of the logs pop up that show the trace IDs. Here you can imagine in a performance analysis situation or troubleshooting situation, you can start to gather some details about the times, where it came from the log file. But then to understand a little bit more, you'll notice that, and something cool about this stack is that you can immediately hop over to the traces from the log. Believe me, this looks really cool on a giant display. So I'm going to go ahead and close out this log file over here since we looked at that, so we can explore the traces bit a little more on my tiny laptop display.
All right. Wow. You're
sorry, go on.
Going for it. Okay. We actually had a question come in from chat. Sorry for pausing. What is the difference between ACLs and intentions?
You can tackle that one, Eddie. So no, that's a good question. So ACLs, as they're known, access control lists, they essentially is what grants an entity access to interact with the Consul server or Consul itself. So think of it, that token that you get gives you permission to talk to Consul and do certain things. The access control list system gives you permissions to certain things. You can create policies, roles, and things like that to simplify the management. But just think of it as your ticket to work with Consul in and out. And I'm oversimplifying here. Intentions is what allows applications to talk to one another. So if we take a step back, Consul is a central registry. All right, it knows where the different applications are. And if we, using a very oversimplified example, if you have application A and application B, maybe you don't want them to talk to one another. So through a Consul intention, you can deny application B to talk from application A. Or maybe you do want them to talk to one another. So you create an intention that allows application A to talk to application B. Traditionally, if you're now using service mesh, if we go back to a more static infrastructure environment, that's normally something you would achieve with a firewall, and you would base it off their IP address or maybe their DNS host name. And it can be a challenge for operations team, engineering team to keep track of who's allowed to talk to one another when you're basing it off IP address, because you can quickly get to a situation where it's like a whack-a-mole. You're like, oh, the IP address changed. And you see that become more challenging in a microservices architecture where containers or instances come up and down and they have a new IP address. So through Consul intentions, because Consul will at all time know their IP address, it's easier for us to know that, hey, just don't let this application talk to this application, or let them talk to it, because the Consul sidecar agent that sits there, they're the ones that are going to make sure that they're allowed to talk to one another. That's a very simplified way, and hopefully that helps address the question. Please let me know if that's not clear enough, and we'll try to explain it in a better way.
Yeah, no, that's great. I really like the analogy to a firewall for the intentions. Yeah, that's exactly it.
Yeah, it's if you, I'll add a link in the chat to some documentation as well. And there are some nuances. So if you enable ACLs, the access control lists, then it's a deny all by default, right? So there are some nuances there, but I'll be sure to add some documentation in chat. And with that, thank you for that question. Eddie, you were showing us a trace.
Yes. Okay. Yeah. So yeah, two more pieces. We saw the logs here in the demo. Two more pieces. Want to go over and take a look at traces. Then we'll go take a look at some of the metrics. But yeah, so here for traces, when we refreshed our service over here, it basically traversed through, sorry, I'm going to stop flipping so many screens. It traversed from ingress through web and then through API, and then went back out to satisfy the request. When you're coming here to analyze the performance or analyze how things are moving through your complete service mesh, this view is a fantastic view. And for those familiar with Jaeger, it's a very, very similar view. You'll be able to see the timings and some of the more details about how that request is traveling through. You'll know what node it hits. And then when you click it, you'll be able to see a little bit more information about the service type and other bits of that. So you know exactly what's happening in your service mesh with each request. So there's logs, there's traces. The last piece that I want to show you is some of the dashboards that we have. And these dashboards are pre-built, customized dashboards. Some of them are available on the Grafana main sites. Other ones you can build yourself. The two that I'm going to show you are available on the main Grafana site and are baked into this. But these show some of the metrics of what's occurring in your environment. So these metrics basically will show you CPU usage over a certain amount of time. It'll show you the RAM free. So when you're getting a total picture of performance in your environment and on your nodes, you can use the metrics combined with the logs, combined with the traces to see exactly what's causing what in your environment, whether it's network throttling, network issues, hardware issues, application issues. It gives you a complete picture and allows you to kind of zoom out and zoom in really quickly to see what's going on in your environment. The other dashboard that we have here, this one shows some of the console details that come through. So it'll show wrath commit times. These are metrics that are being scraped from console. This is a single node console service, so you may not see a huge amount of things here. It's not very busy at its current point, but as you have a more robust console service, you'll see a lot more of these metrics come through. You can figure how like some of the health stats of your applications. This one's console, you can have other ones as well in here. So yeah, basically that is the end of my demo. We talked about basically what observability means, the value of some service mesh observability, and then we got some hands-on experience with using these concepts of the demo. So to take this a little bit further, I'd highly, highly recommend, and I'll stop sharing here. Basically, just check out some of the posted resources that Rosemary is going to send out on Learn in our GitHub repo. We have other quick deploy Docker Compose environments like the secure environment that we were talking about before that are dramatically going to speed up your learning of microservice architecture and service mesh concepts. Also for this, just try popping open the hood, for this configuration file, for this demo, start playing some of the configuration files, tweak the configs, throw in some new services. You can substitute tempo out for Jaeger. Just creating your own scenarios is another great way to speed up your learning. But yeah, that's it. Thank you so much.
Awesome. Thanks, Eddie. So I have a couple of interesting thoughts, notations. If you turn on, so some of these things, some of the metrics you showed, right? If you turn on Consul, you add it to your system, then you get these metrics and some of this telemetry by default. But do you get traces by default? Or do I have to add a few other pieces of instrumentation in my application to make sure that I actually run the traces? Because you showed a list of the traces, and I'm curious if you added any particular instrumentation.
Yeah, no, that's a good question. I think, so there's a little bit two pieces to it. So the metrics, while they're there by default, to get them in Prometheus format, there are some specific console configurations that you have to add for those to become Prometheus format for ingestion. So that's one thing you have to add in configuration to get that. And that's all noted on our website and in some of our Learn guides. So real simple to do, just a small stanza. As for the tracing stuff for Zipkin, there are a few configuration files that are necessary to add. Some of those were done in the application service and through the proxies. I don't know the exact details there. I collaborated with some of the other teams and the developer advocate teams to get that enable environment. I'd like to do a little research on that and post that later on to make sure I give an accurate answer.
Yeah, it's actually, so Fake Service is a Golang application. I posted that in the chat. And if you check for those who are in chat, if you check Fake Service, I believe there are tracing injectors in there. So there's some code that creates the spans. Actually, is anybody able to give a really quick overview of distributed tracing and what traces are exactly? Or we'll fumble our way through it.
Yeah. And also, one of the links that's going to come through, because I'm going to be fumbling my way through it to a degree. Distributed tracing is pretty complicated. We have a blog link where we talk about it. Peter McCarron talks about console tracing and gets into more details of the pros about that. So we'll send that out also as part of this. Goes into more detail, but from a high level detail, distributed tracing is understanding how a request moves through a service mesh. And so if you think of like an HTTP error code, like HTTP 404, something like that hits your service, it may have traversed through a large portion of the mesh and had an error on a specific component in your stack. And that component failed. And so the entire stack basically sent you this error code. Like from a user perspective, you're like, this thing broke. But from someone who's behind the scenes, a developer or somebody who actually knows how this whole application works and is built, they may also be confused, but they can use tracing to drill in a little bit further to figure out exactly which piece of that stack is causing the issues and either replace the node or need to do something with the code or infrastructure behind it to fix it.
Awesome. Yeah, for those who are curious, I attached the blog in the chat. There's also something to note that you can't add tracing to everything. So be aware of what protocols your services are using. For example, some databases you can't enable traces on. You might want to, if you're doing something like Spring or .NET, you may want to add sort of a built-in application instrumentation instead of your service mesh. You can use your service mesh, but in terms of traces, you'll get just the proxy interaction. You're not going to get the transaction itself on the database. So for example, if you're using .NET and you're using Microsoft SQL Server, Envoy does not necessarily collect the traces for Microsoft SQL Server. That's a protocol, a unique protocol. So be aware of what services you have and what they can reasonably trace and where you can add your instrumentation. You may not be able to add it within the service mesh. You may still need to add it within your application itself. So that was something that tripped me up.
That is a great note. Thank you.
Oh, that was I spent 2 days banging my head against the wall about that one.
The main challenge with distributed tracing is mainly keeping track of the context. And even if whether you're using service mesh or not, you see this in hybrid architectures quite often. Let's say you're going from Azure back to on-prem. It can be difficult to keep track of that context. And that's where some of the instrumentation challenges that Rosemary mentioned is where that's needed, where Consul can help you if you have the service mesh extend with, let's say, Azure back to on-prem, and you're using Consul and those two data centers talking to one another. Consul can help fill in the gap in the context because you can use that as the common correlation pattern when you're doing your tracing. Assuming you have the same logging system on Azure as you have on-prem, so example, maybe Datadog, Splunk, because that's the main challenge for operations teams and engineering teams is identifying the context. One thing that is worth being aware of is that with Consul, you do get some very, very limited, I don't even know if tracing is the right word, but, and maybe Eddie, you can show it if you open up the Consul UI, but Consul will show you how it's doing when you connect to another service. Very limited information, and some of it you have to turn on, but it's not intended to help. It's not intended to replace any of the logging monitoring solution, but as a quick identification for like, there's something going on here that I might want to investigate further. So if you click on that at services and go to routing, you can kind of see more detailed information. So in the Consul agent, you can enable some of the settings, and the UI team is expanding on this more, but you'll be able to expose a little bit more information. And in the Consul agent configuration itself, you can expose that information because, like Rosemary said, the sidecar has a lot of information, but it doesn't have everything. But you can export that to your logging, your primary logging solution, like Splunk, Datadog, maybe CloudWatch if you're using that on AWS. And that will help fill in the gap. So if you turn on some of the logging monitoring in the sidecar agent, you will get more information on this screen. But again, it's not intended to replace anything. It's more to help you as an operator or engineer identify like, yeah, maybe that latency is a little bit rough. And I kind of wish we would have done it for this demo if I would have thought ahead. But just be aware that you do get some capability out of the box from Consul.
I love the visualization, by the way, like as Karl pointed out. So if you use 1.9, you'll be able to see, I guess the correct tooling ecosystem is application dependency mapping or something, ADDM, something like that. I don't remember entirely, but yeah, it's not 100% everything, right? But it does show, and at least you'll be able to see what is connecting to what. So we'll be able to see, and a fake service shows this, as Eddie pointed out, like ingress connected to web API and then web.
Ingress web API.
Ah, thank you. Yes. But you can actually see that in Consul 1.9 plus, I think.
About right. Yes.
Yes. All right. I think the questions are slowing down in chat. So is there anything else, Karl or Eddie, that you recommend people look at or they can do to learn more either about observability, the Grafana, Loki, Tempo suite that Eddie was showing, or even Consuls and the microservices kind of implementations that, yeah. Mm-hmm.
I think, as much as I want to nerd out about all the Docker Compose stuff, because I really like it, I think it's just really nice for everyone to get their hands on really easily. Another very valuable resource that we have is we have a microservices learn collection that talks about some of the benefits of using microservices, and we'll move you through a story of using these microservices. We also have that in the URLs that we'll send out as well. That's really nice to be able to put a story behind why microservices are so nice.
Yeah, I guess the last thing I'll share is that definitely check out our learn.hashicorp.com to learn anything you want about Consul. Every tutorial at the very bottom, you can provide us feedback. If it's something that's confusing you or not hitting the mark, feel free to provide feedback there. Rosemary shared my email address, so if there's things that you want to say to me, because I'm one of the managers in charge of that, if you think we're not hitting the mark or we think we can improve, I'd love to hear that, so feel free to send me feedback. I'll ask you to be kind, but yeah, we're welcome all feedback. And of course, if you like this, doing the stuff that Eddie, myself, and our team members do, and you want to be an education engineer, check out that job posting that we have. You don't have to be an expert. All we're looking for people with great attitude and that are fun to work with. So, isn't that right, Rosemary?
Yes. I want to work with you. I don't know if that's a compelling call to action or not, but hey.
We'll take you any day, Rosemary. But no, seriously, yeah, just keep attending these sessions and yes, stay hungry, keep learning.
Awesome. We actually have a comment for feedback for the next one, which is the next office hours console only for multi-data center, no microservices, good old VMs, Linux, and Windows. I can't say we won't do it, but we can do it. So I'll bring that back. We do have some mixed workload demonstrations. So maybe I'll bring one of my colleagues on here and we can show Windows and possibly Linux as well on VMs.
Maybe even showcase some Nomad love in that scenario.
Yeah, I know. Yeah. So it is possible. Thank you, Gabriel, for mentioning that. It is possible. And it is definitely a great office hours. And we'll try to incorporate that into the feedback. All right. So now I guess we're going to close out a little early today. If you tune into office hours on a regular basis, we have Terraform plugin SDK office hours next Thursday, June 24th. You can always check the latest office hours on our webpage. Otherwise, you could check the webpage or subscribe to our channel. That is also one way that you'll get notifications. We'll probably have Boundary and Waypoint office hours happening this month. Stay tuned on exact dates. If you have any ideas, suggestions, or thoughts on what you would like to see, post in our Discuss forum. We'll be able to take a look and suggest that feedback. So with that, thank you, Eddie. Thank you, Carl, for joining us today. And for those who are on the stream, we appreciate you tuning in and watching the chat. With that, have a great day.
Thanks, everyone.
Thanks, y'all. Thanks, Rosemary.
Rosemary.